Okay, assalamualaikum and welcome back, guys. So we proceed with example 3. We are still in first shift inverse. Okay, so this one. So what is your s minus a term? This one, s minus 1. So rearrange the numerator part so that it will be s minus 1 without changing the problem. So therefore you will have this one is equals to 2. So you have to have a bracket here. So this is s that you are going to change to be s minus 1. So what you need? S minus 1. So minus 1, then you need to plus 1. Close bracket. Okay? Plus 1 over s minus 1 squared minus 9. Okay? So this plus 1 here is not this one. Okay? This plus 1 here is from here because you have negative 1, so that's why you have to have plus 1, so that when you expand this one you will have s. Okay, so be careful when you expand this expression. Okay, so expanding this one will give you 2 s minus 1, the first one. The second one is 2 times 1 is equals to 2 plus 1 is equals to 3 over s minus 1 squared minus 9. Where did I get plus 3 here? From this one. 2 multiplied by 1 is plus 1, which is equals to 3. Okay? So since this is plus, so you need to apply linearity properties. So therefore, the inverse of 2s plus 1 over s minus 1 squared minus 9 is equals to the whole thing here, the inverse of 2s minus 1 plus 3 over s minus 1 squared minus 9. Okay, so by applying linearity properties, so factorize 2 will give you 2. So the first function is inverse of s minus 1 over s minus 1 squared minus 9. So this is the first function. Plus, so the second constant is 3. Inverse of 1 over s minus 1 squared minus 9. Okay. So since the numerator part is already equals to denominator part, then only you can apply first shift properties. Okay, so define your A. So since you have, so the general is s minus A, and what you have is s minus 1, so you know that your A is equals to 1. Same goes for this one. Okay, s minus A, this is s minus 1, so your A is equals to 1. Okay, so therefore the inverse of this one, or we can write it as ft. Okay, therefore your ft is equals to 2. So you will have exponential term, so exponent at, exponent a is equals to 1, so exponent t. So inverse of, so remember when you have the exponential term here, s minus a will be replaced by s. So this is s minus 1, so you will have s over s squared minus 9 plus 3 exponent t inverse of 1 over s squared minus 9. Okay, so this one here, s minus 1 replaced by s. Same goes for this one. s minus 1 replaced by, okay. So you can get this one directly from the table. Define your e, because this is negative sign, so it will become cos hyperbolic function. This is sine hyperbolic function. Okay, so your e squared is equals to 9, so your e is equals to 3. This one here, your e squared is equals to 9, your e is equals to 3. So supposedly here it should be 3. But as you can see here, if you don't factorize 3, then you don't have to do anything. Okay, but I always ask you to just factorize whatever constant you have first. Okay, so if you need to multiply by 3, then just multiply by 3, divide by 3. So this one can cancel out. Okay, so why I need to multiply by 3? Because your a is equals to 3. So therefore your last answer is ft is equals to 2 exponent t cos hyperbolic 3t plus, since this one you already cancel out, so you will have exponent t sine hyperbolic 3t. That's it. Okay, so let's take a look at the last example. So let's consider if you have your fs is equals to, so this is more complicated. Okay, if your fs is equals to s over s plus 3 squared plus 1 minus 6s over s minus 1 to the power of 4. So this one you need to apply first shift. This one is also first shift because you have s minus 8. Okay, so I advise you to do it separately, then only you combine your answer. If not, it will become messy. Okay, so let's consider this one as equation 1 and this one as equation 2. Okay, so now we solve for the equation 1 first. Okay, so for your equation 1, your fs is equals to s over s plus 3 squared plus 1. So rearrange this function so that you will have this one is equals to, so what you need is s plus 3, this one, so s plus 3, then you need to minus 3 over s plus 3 squared plus 1. Okay, if you expand this one, you will have s. Okay, that's how you are going to check either you are doing it correct or wrong. Okay, so the inverse of this one, Laplace inverse of fs is equals to, so inverse the whole thing here. I don't want to write it because I already have this one, just the same thing. So this one, the inverse of s plus 3 minus 3 over s plus 3 squared plus 1. So here you need to apply linearity properties. Okay, why linearity properties? Because you have a plus sign here. Sorry, because you have a minus sign here and you have two functions. Okay, so split it into two functions. So apply linearity properties. Okay, you need to know step by step what you do, what you should do. Okay, so that you don't lose. Okay, so by applying linearity properties, so this one, the inverse of this one will have ft is equals to, so the first function s plus 3 over s plus 3 squared plus 1 minus 3. Okay, inverse of 1 over s plus 3 squared plus 1. Okay, so now you can apply first shift properties. Okay, so here you need to apply first shift and also for this one. Okay, so define your a. So s minus a, what you have is s plus 3. So you know that your a is equals to negative 3. So same goes for this one. Your a is equals to negative 3. Okay, so when you have the exponential term, so you need to replace your s plus 3 with s. Okay, same goes for this one. S plus 3 you need to replace by s when you have the exponential term. Okay, so therefore this one is equals to exponent 3 negative 3t because exponent at, so a negative 3t inverse of, so when you have exponent, so replace s plus 3 by s, so you will have s over s squared plus 1 minus 3 exponent negative 3t inverse of 1 over s squared plus 1. Okay, so you can directly get from the table for this one and also this one. For this one, your a squared is equals to 1, so your a is equals to cert 1, which is equals to 1. Okay, so you already have 1 here, so you don't have to do anything. So you can get this function and the inverse of this function and this function directly from the table. So therefore, your ft is equals to exponent negative 3t cos t minus 3 exponent negative 3t sine t. This is not yet the final answer, okay, because this one is for equation 1. So for equation 2, so what you have is your fs is equals to 6s over s minus 1 power 4. Okay, so I just take this function. Okay, later when I have the inverse of this one, then I minus by the inverse of this one. Okay, so I'll rearrange the numerator so that it will become the same as denominator. So you will have this one is equals to 6, so you need to have a bracket, s minus 1 plus 1 close bracket over s minus 1 to the power of 4. Okay, so therefore the inverse of fs is equals to the inverse of the whole function here, 6 s minus 1 plus 1 over s minus 1 power 4. So this one is equals to, so simplify first. So this one multiply, so you will have 6 times by s minus 1 plus 6. Okay, where did I get plus 6 here? It's from here. Why we don't have any value right here? Because you just have 6s. Okay, if you expand this one, you will have 6s. Minus 1 plus 1 is equals to 0. 6 times by s, so you will have 6s. Okay, so the whole thing over s minus 1 to the power of 4. So since you have a plus sign here, so you need to apply, and you have a constant here, so apply linearity properties. Okay, so therefore the inverse of fs, which is ft. Ft is equals to, so the first function, what is your constant? 6. So 6 inverse of s minus 1 over s minus 1 power 4 plus, so another constant is 6, so inverse of 1 over s minus 1 power 4. So here you can already apply first shift properties. Okay, why? Because the numerator part is already equal to denominator part. Okay, but as for this one, you can cancel out first, so this one will become 3. Okay, so let's just rewrite it again. Oh, no need lah. Okay, so just define your a. Okay, so s minus 1, s minus a, what you have is s minus 1, so you know that your a is equals to 1 for both cases. Okay, I just write it once. Okay, so therefore your ft is equals to 6, so exponent at, so your a is equals to 1, so exponent t, the inverse of, so since this one you already cancel out, right? So you will have 1 over, so s minus 1 need to replace by s, so this is q. Okay, plus 6 exponent t inverse of 1 over s 4. Okay, remember when you have the exponential term here, so s minus 1 need to replace by s. S minus 1 here replaced by s. That's why you have this expression. Okay, so that's why you cannot directly get from the table yet, because your n here is not equals to this one. Okay, so define your n. Since this one is n plus 1 is equals to 3, so your n is equals to 2. So supposedly here is 2 factorial. Okay, so multiply by 2 factorial, divide by 2 factorial. Okay, so here your n plus 1 is equals to 4, so your n is equals to 3. So supposedly here is 3 factorial. So times 3 factorial, so divide by 3 factorial. So that's why I told you, you should by now be able to guess what is the inverse of the function. Okay, if not you might have a problem first to define what is the function, then what you need to do, multiply, or you don't have to multiply. Okay, so as for this case, why I need to multiply, because I'm using this one, n factorial over s n plus 1. So I have to make it in this form first, then only I can have t to the power of n. Okay, so simplify your expression, will give you, so 2 factorial is equals to 2, so 6 divided by 2 is equals to 3, exponent t, then you will have t squared, plus, so 3 factorial is equals to 6, so 6 divided by 6 is equals to 1, so you will have t cubed exponent t. So student, my eyes, can I write in this form, or can I just write t squared in front? Yes, properly is written in this way. Okay, but if you write in this way, I also accept it. No worries. Okay, so therefore this is your ft for the second expression. This is your ft for the first expression, for the first function. So you need to combine this one for you to get your real ft. Okay, So by combining equation 1 minus equation 2, why I have a minus sign here? Because this one is minus. Okay, so what is the first function? Exponent negative 3t cos t minus 3 exponent negative 3t sin t. Am I right? Okay. Minus, so this is the first equation, minus with the second equation 3t squared exponent t plus t cubed exponent t. So therefore you will have your ft is equals to e negative 3t cos t minus 3 exponent negative 3t sin t. This one will be minus 3t squared et and again minus t cube et. That's it. Okay, so I already showed to you from this simplest example to the complex example. So I hope by now you should be able to understand when we are going to apply first shift properties for inverse Laplace transform. Okay, so I just want to remind you that it is just me to divide the first shift into two cases, okay, because for you to understand better. Okay, so remember case 1, you just have 1 as minus a term, which is for the denominator part. Okay, whereby for case 2 you also have the s variable or s plus something or s minus something for the numerator, and you have s minus a for the denominator part. So you need to reduce this one so that it will become the same as the denominator part. Okay, when this one become the same as denominator part, actually what you are doing is reduce from case 2 to case 1. Okay, so please try to do the exercise in your notes, and if you have any problem, so please let me know. It's either through WhatsApp or at module. Okay, so I shall see you in my next video, which is for the last properties of inverse Laplace transform. Okay, we have another one, properties of inverse Laplace transform. Okay, so thank you guys. Thank you and see you in my next video. Assalamualaikum.